Hi, Ari. Hi, Ari. How's it going?
Good.
Good. Hi, Jenna. Hi, Nico.
Oh, wow.
Morning, Jake.
Morning.
I'm just going to give another couple minutes before I really get started, but were you guys able to watch the video for 3.3 and take the notes for like the first half?
Yeah.
Yeah, Ari, Jenna,
Yeah.
Jake, yes. Okay, Jenna, Nico?
Yeah.
Yep. Jenna? Jenna, I think you need to turn your voice on, your audio on. All right. Jenna, I don't think your audio's on though. All right. So I will assume that everyone's had the chance to watch the video. Were we understanding it a little bit with the unit circle? What was going on there with the unit circle? So we had talked about the unit circle before, right? Circle with a radius of 1 centered at the origin. So just a couple of things from our old definitions. So maybe I'll just kind of quickly recap in case anyone, we'll just kind of quickly recap. So in your notes, so you should have taken these down, right? All right, so here's the formula for a circle with radius 1. And S equals R times theta. But if our radius is 1, that gives us, so if our radius is 1, that gives us that S is the same as theta. So like you notice that they're naming them with S, which is essentially just theta, right? So it just looks a little different if you're kind of confused as to why we switched over to that. Also, like in the very first unit that we did, we talked about the sine of theta. We usually use theta for these, equaling what in terms of x, y, and r? You guys remember? It's on that,
It's y over r.
right. So normally we had y over r. And if r is 1, though, the sine of s is just y. So when we are talking about circular functions, it's assuming that the radius is 1. So now we're just going to use that the sine is y. So that means cosine was x over r, and we're just going to use x now, right? Because x over 1 is just x. Tangent stays the same as y over x, cotangent x over y. Secant becomes 1 over x, and cosecant becomes 1 over y. That makes sense? So that's just a quick little recap of what is going on here. Are we good with that?
Yeah.
Trying to. All right, so did you guys follow the domain and range of these circular functions? So I just want to point out on this unit circle with a radius of 1, what would this point be?
1, 0.
1, 0. Up there at 90 degrees.
0,
1.
0, 1 at 180. Negative 1, 0, right? And then 0, negative 1 there. So when you took down the notes, when it was going over the domain of these circular functions, since sine and cosine had no denominator, they could be anything, right? Does that make sense? Tangent and secant, the reason why they're grouped together is because they both have x in the denominator. So basically what the notes that you should have taken down from that section. Hi, Jenna. Jenna's just connecting. Hi, Jenna.
Hello.
Oh, good. I can hear you now. Are you
Yeah.
having internet difficulty, or did you just join wrong?
It was internet difficulty.
Okay.
It was, everything wasn't responding, and I'm like, maybe if I refresh it, and then it kicks me
Yeah.
out.
Oh, okay. So I just kind of quickly went over the notes that you should have taken from 3.3 with the unit circle. Like I kind of just am quickly recapping this. So for tangent and secant, you can't have x being equal to 0, which is in the denominator, right? X cannot be 0, which happens, where is x 0? Here and here. And if I go around again, where it lands again, those coterminal times as well. So we're using radians now. So 90 degrees is the same as what? So 90 degrees was the same as pi over 2, right? Radians. And where else is x 0? So this is where, what is this here in terms of radians? What's 270 degrees in terms of radians? So this is 0, pi over 2, pi. This is 1.5 pi or 3 pi over 2, right? And then this is 2 pi again. So at 3 pi over 2, but then if I went around again, it would keep happening. So the way you took those notes, you actually said, in order to capture all of those, it was the way to hit, these are all odd numbers. So the next time it would happen would be 5 pi over 2, 7 pi over 2. Does that make sense? So the way we wrote that was just an odd number. So you make it even and then you add 1 times pi over 2. Does that make sense?
Mhm.
Okay. And cotangent and cosecant, the reason why those are grouped together is because y is in the denominator. Okay. So again, so y cannot be 0 because I can't have 0 in my denominator, which when is y 0 on this circular function? At 0, at pi, and then again at 2 pi, so on and so forth. Does that make sense? So that's pi, 2 pi is where that's going to happen. So the way we did that, it's any multiple of pi, right? So we said n times pi, where n is an integer. Does that make sense for all that? Does that kind of put things in perspective?
Yeah.
Okay. So another thing in that video that I really kind of want to go over, and it talked about filling in that unit circle sheet. Did you guys all watch it? I think it was like the last 15 minutes or so of the video. Does
Yeah.
that make sense on how to fill that in? So it was really just putting what it is in degrees. You should know how to convert it to radians. And then it talked about all these values, which are points along the unit circle. And so the x coordinate, what did we just say x is? It's the cosine of that angle, right? And y is the sine of that angle measure. Does that make sense on how to fill that in? So when you fill it in, it was here. Does that make sense? By the way, I usually give a quiz on this and filling it in because it's important to know and understand that. I don't know that I'm going to do that while we're meeting remotely like this, because that picture is right on page 111 in your book. So if you need to know how to fill that in, and I might give a project that has to do with just so you get used to writing it out, but it's on page 111, and I think we know how to do the conversions, right? And then there's a pattern to these. So in the first quadrant, the x and y coordinate are both going to be positive, right? In the second quadrant, the x coordinate's negative and the y coordinate's positive. In the third quadrant, they're both negative. And in the fourth quadrant, x is positive, y is negative. But if you notice, other than the signs, this one matches up with that one. This one matches up with that one. That one matches up with that one. And then you can do the similar thing. This one matches up with that one. That one matches up with that one. That one matches up with that one. And over here, again, this one matches up with that one. That one matches up with that one. That one with that one. Or you can almost go across that way also. Does that make sense? What does that have to do with why are they matching up? Because you're looking at the, what would you be looking at in order to get the sine or cosine? So cosine's x, sine is y. If you were to drop this down, what am I looking at? What's that called right there? If I were to drop, sorry, what?
A right triangle?
Right. If I make and form that right triangle with the x-axis, what is this called? This angle here. We know here to here is the 150, right? So how much is that?
30.
30. And what's that called?
Reference angle.
Reference angle. So these are going to match up because the reference angle is 30, which is the same as, so it's going to have that same measure as our 30 degree, except for the sines. Does that make sense? Questions? So in that video also, Miss Sabia kind of went over a pattern with like, so that every 30 degrees. So if you notice that this is pi over 6, right? This is 2 pi over 6, because that's the next 30 degrees, right? But what is 2 pi over 6 reduced to? Pi over 3, right? The next 30 degrees would happen at 90 degrees, which would then be 3 pi over 6, which reduces to pi over 2. And so on, so on, so on. Does that make sense? All the way around the pattern. And every 45 degrees is just another multiple of pi over 4. So this is 1 pi over 4. This is 2 pi over 4, which reduces to pi over 2. 3 pi over 4. 4 pi over 4, which reduces to pi. 5 pi over 4. 6 pi over 4, which reduces. And 7 pi over 4. 8 pi over 4 is the same as 2 pi. So do we see the pattern, how this would be kind of easy to fill in questions on that unit circle? So that was like a big thing. And then to fill in the rest of these on your notes, you were really just looking at this unit circle, which if you guys need to see it, it's on page 111. So you could look at page 111 and fill that in. Does that make sense? Mm-hmm. How you would answer these next one? Any questions on these examples? Any questions on anything so far?
Nope.
No? By the way, I'm trying a different way of recording this. If you remember yesterday, not yesterday, 2 days ago, I forgot to hit record with you guys until the end. So I tried to recap some of what we had done in case someone watched the video later. I uploaded the videos, no problem, but my next class, my B block class, I remembered to hit record right at the beginning, but it was about an hour-long class. And I think in order for me to upload it in Google Classroom, it's probably gonna be like less than an hour because they weren't able to access the video. So I have to figure out, and I need my tech husband to help me, how to compress those videos to upload them to like YouTube or something, because I can't even upload them onto YouTube because they're too big right now, or that one is. So I'm trying to record through Zoom. I was just recording through the hover camera, but I'm recording on Zoom, so they might look different if you access them and things like that. All right. So I think you probably filled in all the way down to here. Is that correct?
Yeah.
Yeah.
So all of the first page. Did everyone get all the examples? Good. Mm-hmm. So you're either using, so these are either landing on, so remember, like just on these ones, the sine of -3 pi. Well, that's going backwards, right? Negative. So this is -1 pi, -2 pi, -3 pi. And it's saying the sine, which is the y coordinate. So it's 0, right? Cosine of that is -1. And cotangent is x over y. So that is undefined because it would be -1 over 0. So some of these were like those, the points along the unit circle, if they were the quadrantal angles, and other ones were similar values to what was on that unit circle sheet or the unit circle in your book. You just might have had to, especially the negative ones, you'd want to think of where you were. Like for instance, -9 pi over 4 is the same as what? And what could I add to all these if I want the positive version? Do you remember like we used to get our angles between 0 and 360? So if we wanted this between 0 and 360, instead of adding 360, what could you add? Anyone? What's the same as 360 in radians?
Pi.
2 pi.
2 pi. So 2 pi, if I have the common denominator, would be the same as 8 pi over 4. Is that going to get me between 0 and 2 pi though? So if I add 8 pi over 4, which is the same as 2 pi, that gets me to negative pi over 4, which is a little bit easier. So like negative pi over 4 means I'm just going backwards pi over 4 to here, right? And so those are going to be your values that you're looking at. Or you can just add another 2 pi to that, which is another 8 pi over 4, and you'd be at 7 pi over 4, which was that same spot we were talking about. Does that make sense also? Questions? All right. So I think the last things is just some calculator work. Does everyone have access to a scientific calculator? I'm sure there's an app too that you could always download. But I think most of us, are all of you using your cell phones, or do you have a scientific calculator?
There's this website called Mathway, and it has a trigonometry generator thing.
Okay.
So that's what I use.
Okay. So you want to kind of get used to, because I don't know, I'd have to check that out, Jenna.
Yeah.
But you want to make sure you know how to do it really kind of in a calculator. So when we get back to school, hopefully soon, well, not soon anymore, but you know what I mean. Hopefully it's May 4th.
It looks like a scientific calculator.
Not pushed off any later than May 4th. So you just want to make sure you would know how to put it in on something like this, right?
Yeah.
So the big thing now, because this is the first time we've really used a calculator to get the approximate values of anything, is I think you guys, can you guys all see that? What mode am I in?
Degree.
Degree. It says DEG. Can you guys see that okay?
Mm-hmm.
And what is this asking us to find in this next example? What does that 3.42 mean? 3.42 degrees?
I think radians.
It's in radians, yes. So if you have your calculator with you, just make sure to change the mode. So again, the mode button's here. So when we get back to school, this would be how you do it, because this is that same calculator. It's right now it's highlighted degree. I just use the cursor, move it over to radians, and then I just hit enter, and then I can quit out of there. And now you see it says RAD. Does that make sense? So I'm using radians. So then it's just the sine of 3.42, right? And you get negative 2748. I think most of the time it's asked us to go 4 decimal places. I know these directions didn't say that specifically. Ugh. There we go. That's a little better. I think it's trying to focus on my calculator and the paper, so it's not. All right, so the next one shouldn't be too bad either. So the tangent of 0.8234. All right, so we get 1.0790 when you round. Is everyone good? Well, how are you going to do secant on the calculator?
Wouldn't you just do 1 divided by the sine?
What's the reciprocal of secant?
Cosine.
Cosine. So it's on the right track, Jenna, just the wrong trig function. Do you remember what I said at the first unit? I remember that the S and the S don't go together. Like it's like the opposite. Do you know what I mean?
Oh, yeah.
Remember me saying that? So
Yeah.
1 divided by the cosine of 5.6041. All right, and you should get that 1.2851. And so then doing the cosecant would be, Jake, what do you think? Trying to get you guys involved. What do you think, Jake?
Right.
How would you do cosecant?
Inverse of sine, I think.
Okay, so we only use those inverse buttons when we're trying to find the angle measure. It's giving us the angle measure, it's just in radians. So
Okay.
we're not going to use the inverse. It's going to be very similar to just how we did letter C. So what do we do for letter C? I think I already cleared it. We did 1 divided by the cosine of that angle. So cosecant is going to be
1 divided by the sine.
good. So 1 divided by the sine of that negative. So remember the negative is here. Negative 2.7335. All right. So you get negative 2.5198. Are we good?
Yeah.
On those? All right. So find each value as specified. All right. So this time, what is it asking us to find? So it only says 0 to pi over 2. So that's actually just means quadrant 1, right? 0 to pi over 2. So so the way you're going to think of it as, that's just going to affect what is happening because of coterminal reference angles. But we're staying in quadrant 1. So what's it asking us to find though? Find the approximate value of S. What is S? What's S? It's the same as
Theta?
using that interchangeably with
Delta.
almost theta. So it's what is S or theta? What have we used for those? Like those are the angle measures, right? But this time, this kind of clues you in that they want it in radians. The S kind of clues you in because I think that's why they're switching between theta and S, using S, is to say we're looking for that angle measure, right? So what do we have to use on the calculator in order to find that angle measure?
Degree.
Anyone? Jake, this is what you were saying earlier. Do you remember?
No, I'm completely zoned out. Sorry.
So it's asking you to find the angle measure. So you're going to use the inverse buttons. Anytime we're asked to find an angle measure, it's using the inverse buttons.
Okay.
So this is where we're using inverse sine. So you have to hit second sine if you have a calculator like the ones at school of 0.3210. All right. And you should get 0.3268. All right, so the next one. So this is why I'm saying, so it's giving you this. Where is 3 pi to 2 pi? What quadrant is that in? Anyone? Nico? 3 pi over 2 to 2 pi. What quadrant are we in?
4.
Right. So that's quadrant 4. Which makes sense because tangent is negative in quadrant 4, right? And we have a negative value here. So when I hit inverse tangent of negative square root 3. Sorry, I'm trying to remember how to do this on the calculator. Divided by, so I had to hit the arrow over to stop it from being underneath the radical. Some of you might have to use extra parentheses on your calculator. Whoops, was it? Oh, sorry. Divided by 3, close parentheses. You get negative 0.5236. So this is a reference angle for the quadrant. So we said we're in quadrant 4. So this is going to be, this is the reference angle that we are using. And also, I'm gonna all right, so how do I get, if that's the reference angle and you're in quadrant 4, and it's actually easier, this is the same as negative pi over 6. So if you're in quadrant 4 and you go pi over 6, do you remember every 30 degrees is pi over 6, right? So that would bring us to 11 pi over 6 in quadrant 4. Does that make sense? Questions on that? That one is a little bit trickier. So how are they getting this value? You could look at your unit circle and try to determine how do we get the tangent of something to being root 3 over 3? Like where would I be on this unit circle? So tangent is y over x, right? So we are getting that tangent y over x. If you kind of look at the coordinates, how are we going to get that? And it happens, I'm going to kind of show you and point out it happens, and I'm going to give that to you there. So the y was root 3 over 2. And, sorry, the y was not root 3 over 2. It was, the y coordinate was negative 1/2 over the x coordinate, which was the root 3 over 2. All right, so complex fraction, remember we dealt with complex fractions before, so you would copy the first one. This division gets changed to multiplication, and you flip the second one. Oh, whoops, didn't flip it. All right, so it becomes negative 1/2 times 2 over root 3. I should really do this in pencil. See why I have you guys do it in pencil? When I'm doing it at the board, I can erase it easily. All right, so the 2's would cancel, right? Become 1's. you'd be left with -1 over root 3. But do we leave our answer like that? Leave a radical in the denominator? You would rationalize root 3 over root 3. You get -√3 over 3. Does that make sense? So where was that? You can also say, where was that on the unit circle? That was at 11 pi over 6 in quadrant 4. Does that make sense? Questions? All right, so the last one, and by the way, all these examples I want to point out, I'm probably not going to spend a lot of time going through them. They are in your book. So it matches up, like every time we do an example, it kind of matches with the example that goes along with it in the book. Oftentimes I would go over these a little bit quicker in class, and then I would have us work on ones together. Does that make sense? So if you need extra, those are them. So this is something I would not have you memorize all this. It's going to be just plugging into the formula. Okay. So it says the angle of elevation theta of the sun in the sky at any latitude L is calculated by this formula, where theta is 0 corresponds to the sunrise, and theta equaling pi over 2 occurs if the sun is directly overhead, right? 90 degrees directly overhead, right? This is omega, is the number of radians that the Earth has rotated through since noon when omega equals 0. D is the declination of the sun, which varies because the Earth is tilted on its axis. Sitka, Arkansas has a latitude of 57.1 degrees. Find the angle of elevation sorry, of the sun theta. Of the sun theta. Of the sun at 3 p.m. on February 29, 2012. And it gives you what D is equal to and what omega is equal to. So this is really just a calculator plug-in information. All right. And so if you set this up, first of all, a couple of things. What are we working in all the time now? We're working in radians, right? So you can see that the L that they gave us was in degrees. So you really want to convert that to radians. So you're going to multiply that by pi over 180, right, to convert to radians. And you can just put this all in your calculator in parentheses, so you don't have to like worry about the long decimal that you might get. So if you plug this all in, this says the sine of theta equals cosine, and it says of D, but D I have here. So negative 0.1425 times the cosine of L, and L was the one we just converted. So I could put that in parentheses as the 57.1 times pi over 180. Does that make sense? Then it says times the cosine of omega, which is already given, 0.7854, plus the sine of D, again, D, we were already given D, 0.1425, times the sine of L, which is this, and I'm running out of space, I should have started, which is that 57.1 times pi over 180. Kind of squeeze that in there, but you guys, there. Does that make sense? So it's really just plugging it in. So once, what I would suggest is you plug that in. So what is it asking us to find? It's asking us to find that theta, right? So we are going to have to use what to get theta? Theta's an angle measure in radians, this is like we're using all radians this time in this formula, right? We're going to be asked to find that angle measure. So we're going to use that inverse sine button. So if you put this all in the calculator, and trust me, it is kind of a lot. I'm going to try to do it on the screen. If you have a calculator, scientific calculator with you, just try it. If not, try it after we, you know, plugging it in after whatever program you're using or app that you're using or your cell phone. So I'm going to try plugging it all in without messing it up. Negative, so that's probably the hardest part. 0.1425 close parentheses times the cosine, and it starts the parentheses, 57.1 times pi divided by 180 close parentheses times, the next one was the cosine of 0.7854 close parentheses. Then it says plus the sine of that negative 0.1425 close parentheses times the sine of that 57.1 times pi over 180. 57.1 times pi divided by 180 close parentheses. So I put everything in the calculator. I hit enter, and that's what you get. Now I'm going to write that down here, an approximation, but I'm going to leave that whole thing in my calculator. So I'm just going to write it down. You should have about 2609. Actually, I'm going to write everything. 47282. So I don't really want to round anything till the end. So I'm going to leave the whole thing in the calculator. And how do I get theta? I hit inverse sine of that equals theta. Okay. So inverse sine. And then in order to get that answer put in, I hit, see how it says ANS above the negative key? So I hit second answer. All right, and that actually almost looks like the same number, but it's not, right? So theta in radians is about 0.264003353. All right. So it says find the angle of elevation. It's actually asking us, how have we normally talked about angle of elevation in terms of degrees? And kind of evidenced here, you know, they gave the latitude in degrees. So to convert this back to degrees, you're going to multiply by what? 180 over pi. So again, if I leave that whole answer in there and I multiply by 180 and then divide by pi, I get about 15.1 degrees. So you might have a couple questions, I think, in the assignment I gave you that have to do with this, and it's really just a bunch of calculator work. You would be given this. I would never expect you to memorize that. And it's all just plugins. Questions? Anyone? Should I leave that up?
Yeah.
All right. So that's it for section 3.3. So any other questions on section 3.3? How about on the loon project? Questions on that? I haven't really checked to see who's handed that in. Ari, have you done it?
I've done a little bit of it.
Okay. Do you, Jenna?
I've only done like the first little bit that I started on Tuesday after the Zoom,
Okay.
but I just decided to do the bookwork first so I could get that out of
Oh,
the way.
the book work, we hadn't even covered it all. That's why I gave the project at the beginning of the week.
I just I just watched Miss Sabia's videos and I figured it out.
Yeah, okay. I mean, that's fine. And again, this part was either just calculator or plugging in a formula. So it really probably, hopefully wasn't too bad. Nico, how about you? Did you do the loon project?
Yeah, I just started the first little bit on Tuesday.
Okay, Jake?
I started a little bit of it.
All right. So I can't stress enough for the loon project, you really want to read through what I gave you. You might have to copy the figures if you don't have access to a printer. You might have to copy some of the figures out on a separate sheet of paper to work with breaking down the triangle in order to calculate the areas and the area of the sectors that you need. But I do think if you read through that and you're taking all that information, you kind of go step by step by step, you should be able to get it. There's a lot of hints on the video that I posted of Miss Sabia doing it. I think I gave a number of hints on Tuesday's video as well. I think most of you were here on Tuesday though. Does it make sense what you had to do for it though?
Yeah.
Yeah.
Okay.
Yeah.
So remember, it's really just figure 3A minus area of the area of figure 3A minus the area of figure 3B. Now to get the area of figure 3A, you had to figure out what like the radius and that theta was, that central angle, right? Convert it to radians. Figure 3B was a little more tricky because it wasn't just the area of a sector. It was like the area of the sector. I'm gonna try to pull it. All right. So here's 3A and 3B. So just a reminder, it's when you take this whole area of that sector and you subtract out this one that looks like a sector, but do you remember we talked about the sector is really this whole thing. So in order to get the area of this shaded region, you have to do the area of the entire sector and you have to subtract this unshaded area, which we kind of broke down into triangles. And using, and then you're going to use 30, 60, 90 triangles to figure out what the area of those triangles are. Does that make sense?
Yeah.
Okay, let me know if you have any questions. Obviously, like, you can't really send it to me and say, is this right? But if you're like stuck on a section, I might be able to say, well, make sure to drop that, you know, drop that angle bisector, which is also a median, down and look at, it's going to form a right angle and things like that. I could try to help you with. But I think this will be enough to get you through 3.3 and the area of the loon, what we did this week. I'm sure you guys heard the message from Dr. Nozick, right? Out until the 4th. And we're gonna hopefully be given a little bit more direction on what we're supposed to be doing at home and what you guys are responsible for. All right?
Yeah.
Anyone have any other questions? Everyone's doing okay? Bored out of your minds?
Yep.
Are you still working?
Yep.
A lot, yeah. You guys going outside? Today's supposed to be a nice day. Get outside, right? Every day. Are your parents putting you on any kind of schedule, like saying you have to do work certain times, schoolwork? Anyone?
Not really. I choose one.
Okay. So I apologize. I know some of you would probably prefer me to do this later, but I'm sure you've seen me write a number of times. I know Mr. Lucas, I don't know if any of you meet with your B block classes or if going forward now after we have postponed it till May 4th, I really think that a lot of you are going to be meeting with your B block, and I just don't want the times to overlap. Does that make sense?
Mhm.
Yeah.
Plus, my kids are still sometimes sleeping till almost 9, and then they do academics 9 to 12, so I can get my work done. So that's how it's going. All right, so get outside today. Jenna, you still have toilet paper?
Yeah.
All right. Stocked up a little bit?
Yeah.
Good. Everybody else is doing okay? How
Yeah.
can we get more people to join us?
I don't know. I talked to Gus, but
Oh, you did?
I guess Gus isn't into it.
You did talk to Gus. Okay, because he hasn't done anything for me yet.
Yeah.
Did he say anything?
He said that he hasn't really looked at Google Classroom, but he said that he watches the videos of the Zoom sometimes,
Okay.
but that's about it.
All right. How about Ben? Anyone talk to Ben or Ryan Sears? Those I
No.
haven't gotten much from. Is anyone curious that's of you guys that are on if you owe me anything still? Or do you know what you owe me? Jake, I think you still owe me the practice quiz.
Yeah, I'll do that.
Okay. Let me just kind of go down. Jenna, looks like you've done everything other than I haven't like looked for the stuff this week, like the Loon project and the 3.3.
Yeah, I haven't passed in the Loon project, but I passed in everything else.
Okay, so yeah, I'm referring back to like last week. Nico, you owe me a couple things, 3.2 and then a combination 3.1, 3.2 assignment. Nico,
Yeah.
good. And Ari, it looks like you're caught up from last week. And then a lot of you already took a little assessment on 3.1, 3.2, so I could see how you guys were doing before you did the practice quiz. Like Jake, did you do the real quiz?
Yeah, I did
like before the practice?
Mhm.
Why?
I also, I mean, I thought the practice quiz was kind of optional.
All right.
So I did it after the actual quiz.
Yeah. Okay. And then the rest of you, Nico, you still have to take that too, right? That assessment, 3.1, 3.2. All right, so I think that's it for today. Did you guys like how I laid everything out like this week for like kind of the whole week?
Yeah.
Was that a little bit better?
Yeah.
All right. Obviously, as we're not going back after 3 weeks, I might need to adjust even more. I don't know if we'll be required to meet every day, during normal class times. I'm not sure of that. I know some classes are meeting every day during class times, especially math classes.
Are we still gonna have April vacation, or are we gonna have to work through that?
I hope we still have April vacation, because I don't know about you guys, but I have been working nonstop this whole time. I've worked probably more than I do in school because it was a huge learning curve. So like last week, I put in way more time than I would have even at school without learning everything. So I have not gotten a break yet. It's been stressful. And especially I'm home with my kids. So sometimes I would love a vacation just we don't work on schoolwork and have some fun and stuff. That's why I would try to catch up, get your stuff done now. I'm hoping we can still have April vacation. Would you like that, Ari?
Yes.
Yes, me too.
I'm more concerned about prom.
I know. I don't know what will happen.
I mean, if prom is on May 8th, and we go back the 4th.
I know.
Maybe squeeze it in.
I know. I don't know what will come out. I'll tell you what, I was a senior class advisor last year, and I'm glad I'm not this year, because to try to figure that out with everything, it's crazy. And I don't even know when seniors will be expected to stop classes. That's my other question, because really, when we go back, you guys only normally had like 2 weeks of school and then it was final exams. So I don't know if that will still be the case or not. So hopefully we get some direction on how long you seniors are in school for, things like that.
Yeah.
And I think my dog wants to say hi. And my son Ryan wants to say hi. Come on, Jack. Come on. Come. There's my dog.
Oh, he's so fluffy.
He is fluffy. He's licking my hand. All right. And then Ryan, I think my son Ryan wants to say hi.
Hi,
There he
Ryan.
is.
Oh,
He doesn't get to see any of you other than Ari because the rest of you don't have your video on. All right. There we go, Jenna. Thank you, Jenna. All right. So I will let you guys get to work. So try to finish it up this week. I'm not going to give you anything else other than what I already assigned you. So just try to get caught up. Get caught up today and tomorrow, and then I'd like you guys to have the weekends off, you know? Okay? So
Yeah.
do your work during the week. Take weekends off. Take a lot of breaks. Go outside. Get sunshine, vitamin D. All right. I'll see you guys next week. I'll post when, I'll try to post a weekly update on Monday or Sunday or Monday. Sound good?
Yep.
All right. Bye, everyone.
Bye.
bye.